when we have any logarithm, it is always considered as the base 10. So when we add all this, 3 log 2 plus 2 log 2 is 5 log 2. 5 log 2 plus 3 log 2 is 6 log 2. If I have to find out the value of 33.76, first I'll write the characteristic. Hello everyone, I am Purnima, faculty in the Department of Commerce and Management, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. I welcome you all to this session. In this session 3 of logarithms, we will be working few more problems on logarithms. Now let us see the problem here. Prove that 2 log root of 256 by 81 plus log 54 by 224 plus log root of 441 by 226 is equal to 0. Now we'll rewrite this problem as 2 log root of 256 by 81 plus log 54 by 224 plus log root of 441 divided by 256 is equal to 0. So this will be equal to, so I'll just bring this 2 here. So I will write log 256 81 to the power of half. I'll take it whole square plus log 54 by 224 plus log 441 by 226 to the power half. Now this will be equal to log of 256 to the power half, that is, so it will be coming up to 16 by 9 the whole square plus log 54 by 224 plus root of 441 is 21 by 16. Now this can be written as log of 256 by 81 into 54 by 224 into 21 by 16. Now we simplify this. So when we simplify this, I get the answer as 0. So the next problem, prove that log 3 to the base 2 plus log 4 to the base 3 plus log 5 to the base 4 plus log 6 to the base 5 log 7 to the base 6 plus log 8 to the base 7 equals 3. So this is a problem based on change of base rule. So I write log 3 by log 2 to log 4 by log 3, log 5 by log 4, log 6 by log 5, log 7 by log 6, log 8 by log 7. Now we just delete all those terms which are common. So we are left with log 8 by log 2. Now this can be further written as log 2 cube by log 2, or I can write it as 3 log 2 by log 2. Log 2 gets cancelled. I am left with 3. The next problem, prove that 1 by log 24 to the base 6, 1 by log 24 to the base 4, 1 by log 24 to the base 8 equals 2. So I can rewrite it as log 6 by log 24, log 4 by log 24, log 8 by log 24. Now this is, I can write it as 2 into 3. So I'll write here log 2 plus log 3 divided by 3 log 2. So this 24, if you can see here, 24, 2 1s, 2 6s, 2 3s, 3 1s. So 2 cube into 3. So that will be 3 log 2 plus log 3 plus 2 log 2 by 3 log 2 plus log 3 plus 3 log 2, 3 log 2 plus log 3. So we have the same base here. So the bases are same. 3 log 2 plus log 3. So I'll add all the log 2 plus log 3 plus 2 log 2 plus 3 log 2. So when we add all this, 3 log 2 plus 2 log 2 is 5 log 2. 5 log 2 plus 3 log 2 is 6 log 2. So this will be equal to 6 log 2 plus log 3 whole over 3 log 2 plus log 3. So log 2 plus log 3, log 2 plus log 3 is common. So I delete it. 3 2s are, so 2 is the answer. Next, prove that log 385 by 5 to the base 4 log 81 by 32 plus 3 log 5 by 3 minus log 9 equals 2. So this can be written as log 384 by 5 into 81 by 32 into, so there is 3 log 5 by 3. So it will be 5 cube and 3 cube. 5 cube means 125, 3 cube is 27 into 1 by 9. Now when we simplify this, it will come up to 5 2s are, 5 5s are. Then 9 9s are 81. Then next will be 3 32, 32 1s are, 32 1s are, 32 2s are. Then, so when we simplify all this, we get the answer as 2 is the answer. Next, logarithmic tables. So how do we make use of the logarithm tables? Logarithms to the base 10 are known as common logarithms. By definition of logarithms, consider the following examples. So when we have any logarithm, it is always considered as the base 10. Now 10 to the power of 0 equals 1, or log 1 to the base 10 equals 0. So we will be taking this number as log 1. So to this number, we are taking log 1. This number will be remaining as the base and the answer will be 0. Log 1 to the base 10 equals 0. Then log 10 to the base 10 equals 1. log 100 to the base 10 equals 2. So why it is 2? 10 square equals 100. So it is 2. Log 1000 to the base 10 equals 3. Why? 10 cube equals 1000. Then log 0.1 to the base 10 equals minus 1. Log 0.01 to the base 10 equals minus 2. Log 0.001 to the base 10 equals minus 3. Now, what about the characteristic and the mantissa? The logarithm of a number to the base 10 has two parts. One is the integral part called as a characteristic, and the other part is the fractional part called as the mantissa. For example, log of 25.63. So, how do you find out the value of 25.63? So, the first thing is you count the number of digits to the left of the decimal. So, how many digits are there? 2 digits. So, 2 minus 1, I write it as 1. 1.4085. So, to find out this value, I have to make use of the logarithmic table. Here, 1 is the characteristic and 0.4085. So, this value has two parts. So, this one will be called as the characteristic, and this part after the decimal point, it will be called as the mantissa. So, 1 is the characteristic and 0.4085 is the mantissa. Now, so I know the value of 1 here. Suppose there are 2 digits, the characteristic will always be 1. Now, I have to find the value of 2563. So, in order to find out the value of 2563, I have to make use of the log table here. So, here in the table, it starts from 31, 32, 33, 34. So, instead of this 31, I have to look for 2563 and then find out the value. Now, see, for example, log of 33.76. See, if I have to find out the value of 33.76, first I'll write the characteristic. So, how do I write the characteristic? Counting the number of digits. There are 2 digits. If there are 2 digits, 2 minus 1, 1 I will write. Then I will just check the log table. 33. So, if you can see here, 3376. So, I'll just see here the table 33 is there. Then 7, 5276, I write it somewhere, and 6. What is the value under 6? It is 8. 5276 plus 8. So, 6 plus 8 is 14. 8. So, 5284. Now, I write after the decimal point whatever the number I am getting. 5284. I am writing it here. Now, suppose the log value of 337.6. There are 3 digits. Then what do? 3 minus 1, 2. I write the characteristics as 2 and the value will be the same, 5284. Suppose I have to find the log of 3376, a 4-digit number. So, 4 minus 1 is 3, 3.5284. Now, suppose it is 0.3376. So, I don't have any number to the left side of the decimal. So, I write it as minus 1.5284. Then, again 0.003376. So, there are 2 zeros here. So, 2 bar 0.5284. This will be the value. The same way the anti-logarithm tables. So, anti-logarithm tables means we are converting the logarithm value back to the whole number. So, here it will always start with the decimal 0.21, 0.22, 0.23, 0.24, 0.25. Now, let us see here the anti-log of 1.2546. So, 1.2456. So, if I have to find the value, I have to first search at 0.2456. So, 0.24. I see the number here 0.24 and 5. So what is 5? 1758. 5 and 6. 2. So 8 plus 2, 10. Borrow 1. 1760 I am getting. Now here 1760 I write as it is, and then I just see the characteristic. What is the characteristic number? 1. So I add 1 to that. So 1 plus 1 is 2. So after 2 numbers, I write the decimal. So 17.60 is the anti-log value of 1.2456. Now, anti-log of 2.2456. So if it is 2.2456, again it will be, I will have to just check it like this way. So antilog of 0.2456. So here if there is 0, then I'll write 1760 will be the same value, but after one number I just add the decimal point. So antilog of 1.2456. So I will just write 0.2456 value and then add 2 digits, and then I'll get the answer. So with this, we come to the end of this session. Hope you have all followed it. Thank you.